There is a reason why programmers love working with Python. Firstly, it's very simple. It's almost like you're writing in English. Secondly, Python has a huge repository of libraries where you can get a bunch of standard operations basically for free. Before you write something complicated in Python, check whether there's a library for that. Most likely there is, and you ought to be using that library instead. You'll often find that developers talk of Python modules and using a certain module, such as NumPy, Pandas, the OS module, and so on. Python modules are just Python source code which has been written for you and is part of the Python library. When you import that module into your file, you're able to use the functions and the variables exposed by that module. Let's take a look at our very first Python module that we'll import into our current file. This import is done via the import command. You simply say import and the name of the module that you want to bring into this file. The math module is a built-in module that's available with your Python installation. If you want to perform some standard math operations in the real world, instead of writing your own code for this, you will use the math module. Let's see the functionality that the math module exposes. Math.ceil will allow you to find the ceiling of any number that you pass in. The ceiling of 3.4 is 4. If you're in a programming or analyst interview, your interviewer might ask you to write code to find the factorial of a number. However, if you're programming in the real world, you'll simply use the math library and call math.factorial. The factorial of 6 is 720. Notice that we've imported the math module and we call functions on this math module using the dot operation. The math module, when once imported into our current file, becomes a namespace. A namespace is simply a logical grouping of functions, classes, variables, and so on. So do not be confused when you hear statements like the GCD function is in the math namespace. It simply means that the greatest common denominator function is part of the math module. The math module, when imported into this file, is a namespace. The greatest common denominator of 40 and 15 is, as you know, 5. Let's move on. You also have the math.pow operation, which allows you to raise one number to another. 2 raised to 5 is 32. The math module also has common constants, such as the value of pi. So instead of setting up a constant by yourself, you'll simply use the pi constant from this module. There's also a variable that holds the value of e. There's also a constant in this module which holds the nan value. Nan stands for NaN, which is not a number. This is a special value in Python indicating that the calculation that was just performed cannot be expressed as a number. You'll encounter this often when you're programming in the real world. Let's say you divide a number by 0. The result is not a number. In Python, it will be expressed as nan. The resultant variable will hold the value nan. If you perform a calculation and you want to check whether the resultant value is a number or not, you can use the math.isNan function to do so. Here, 4 is clearly a number, so isNan is false. Here is another useful module in Python. This is the random module, and you can access the functions and variables in this module by calling import random. The random module contains a number of different functions which allow you to make random choices, shuffle your data, and so on. Here, random.choice allows you to make a random choice of the items in the list that you've passed in. The element from the list that was chosen at random will be stored in the choice variable. And if you print out choice, you'll see that it has some value. I don't know what value will be displayed. Here random.choice has picked the element G. If you hit shift enter on this cell multiple times, different elements will be picked. Let's say you have a list of items. These items can be anything. You can use the random.shuffle method in order to shuffle the items in this list. The items will be shuffled and the list will be updated. Another useful module that Python programmers use fairly often is the OS module. This allows you to examine the contents of your current local machine. os.getCwd allows you to know what the current working directory is. This command will give you the absolute path to your current working directory where this file is. The os.uname function gives you the name and other details of your current operating system. I'm running on a Mac. You can see that the node name is MacBook Air and other details such as when this OS was installed and so on. The os.listdir directory is basically the ls command that you'd run on your terminal window. This will list all the files and directories under the current working directory because we specified dot as its input argument. I have all the Jupyter notebooks for this course in the same directory, and that is what is listed out here. The OS module also allows you to create a new directory using the mkdir or the makedir command. I want to create a new directory named new_dir under the current working directory as indicated by dot. Once the new directory has been created, I will list the contents to see whether the new directory is now present. Remember the listdir command that we used previously. Here you can see that new_dir is present in my current list of directories. It wasn't there earlier. You can also rename your files and directories using the OS module. Here I'm going to rename new_dir to old_dir. We'll once again check whether the rename was successful by calling the os.listdir function, and you can see old_dir there. Rename was fine. If a directory is empty, you can use the rmdir function to remove directories as well. We'll confirm this with a listdir, and you can see that old_dir has disappeared. It's gone. If you just want the name of your operating system, you can use os.name to access it. OS here can be thought of as a top level namespace, top level because there are other namespaces within the OS namespace as well, such as os.path. The path namespace also has functions that are useful to us. Let's check some of those out. Notice how I call the exist function under the path namespace under the OS namespace, os.path.exist. The exist function can be used to check whether a file path or a directory path exists on your local machine. Here I'm checking whether the /temp folder exists, and it does. The os.path.exist function works with absolute paths as well as relative paths. So you can specify relative paths under the current local directory as well. The text on screen shows you an example of a local path. The actual code is another example of where we use an absolute path. An easy way to remember is that absolute paths always start with /. / is the root of your local machine. This is true when you're working on a Mac or a Linux machine. If you're on a Windows machine, the drive itself, C:, or D:, is the beginning of any absolute path. User local bin also exists on my local machine, so the return value from the exist function is true. Instead of having to continuously type out os.path.exist, it would be simpler if we could use path directly. You can do so if you set up your import statement in this manner. From the OS module, you want to import path. Path is now accessible directly. Path.appspath will give you the absolute path to any folder that you specify. Here we are going to get the absolute path to our current working directory, represented by dot. Thanks to our more specific import statement where we imported path from the OS module, we do not have to have the OS prefix before we access path. And this prints out the absolute path to the current directory. You can check whether a path that you've specified is a file or a folder. Here, dot refers to the current working directory, which is a folder. Path.isFile returns false. Let's try with a real file that exists in this directory. I'm going to list all files in this directory first. Here, I'm going to choose one of our Python intro files. Path.isFile for demo1 will return true.